Hi, good evening, everyone. Am I audible?
Yes, audible.
Yeah, so today is week 9 solve with this session. Now let me share my screen.
No, ma'am. Week 7, please. Week 7 and 8.
No, today is week 9 solve with this session. Week 7 and 8 are already done.
No, done. Week 7 and 8, please. Revision. Because in night session, week 6 and 5 and 6 is already revision, so 7 and 8.
I think they are covering the week 9 because week 9 deadline is tomorrow.
Yeah,
But in quiz 2, not included. Week 9.
so check your calendar. It will be scheduled
Yeah,
on some other day, maybe. Okay.
I'm check, but ma'am. So quiz 2 is very near, so week 7 and 8.
So I think week 7 and 8 revision session is tomorrow. Okay. So
Okay.
today it's week 9 solve with this session. Tomorrow it will be. Yeah, my screen is visible now.
Is the recording on, ma'am?
Yeah, it's on. My screen is visible to you people.
Yes, ma'am.
Okay, so join the peer deck. Please join it fast. Only one student, three students have joined it. So should I start now?
Sure.
Yeah. So this is your question number 1. So here, let x1, x2 up to xn are IID samples from a distribution x with mean mu and standard deviation sigma. Okay. And this is your estimator given. Okay, mu cap for mu. Then you have to find the risk of mu cap. Have you all done?
Yes, ma'am.
Okay, how did you solve this question? What did you do first? Okay, what is the correct answer?
See, first
Okay.
actually we need to find the error or bias.
Hmm.
Yeah, which is the expected value of mu cap minus mu.
Yes. Then.
So once we get the error or the bias, keep it aside
Hmm.
and find the variance,
Yes.
variance of mu cap, and then once we get the variance of mu cap, it will be the variance plus the whatever we got earlier, that mu, the error square will give us the
Yeah,
answer.
bias square. Yeah,
Bias
so rest is equal to the bias square plus variance. Okay.
variance.
Yeah. So this is your solution. So first of all, we'll find out the bias. Okay. And how will you find the bias? So bias is nothing but the expectation of error, right?
Yeah.
Okay, let me solve this
Yes,
question.
ma'am.
Okay. So bias of mu cap will be equal to the expectation of error. Okay. And error is what? Mu cap minus mu, right? You can call it as mu cap or mu hat also. Okay. So we have to find the expectation of mu hat minus mu. Okay. And mu hat is given to you in the question. You can see that mu hat is equal to 20 times xn plus x2 up to xn divided by n. Okay. So we can write it as expectation of 20 x1 plus x2 up to xn divided by n minus mu, right? Okay, so it will be 20 by n. Okay, so 20 divided by n is constant, so we can write out of the expectation. Okay, and then it will be expectation of x1 plus expectation of x2 up to expectation of xn, right? Is this clear?
Yeah.
Okay, and then expectation in the question we can see that all are IID random variables, okay, with mean mu and standard deviation sigma. Okay, so each of the random variable x1 x2 up to xn all are having mean as mu. Okay, so it will be n mu, right? You have to add mu n times, so it will be n mu, right? So it will be 20 mu minus mu, so bias will be equal to 19 mu, right? Is it clear?
Yes, ma'am.
Okay,
Yes, ma'am.
now we have to find out the variance. Okay, so variance of mu cap, so it will be 20 now 20 divided by n is constant, so it will be 20 by n whole square. Okay, and variance of x1 plus variance of x2 up to variance of xn, right? And standard deviation is given to us, which is sigma. So variance will be sigma square, right? And we have to add it up to n times because all are IID random variables. So it will be n sigma square. Okay. So it will be 400 sigma square divided by n, right? Now we have to find out the risk. Okay, and we know risk is equal to the bias square plus variance. So bias we have calculated it as 19 mu. Okay, so it will be 19 mu square plus variance is 400 times sigma square by n. Okay, So 19 square, which is 361 mu square plus 400 sigma square by n. Okay, so in the given options, we can see that option number C will be correct, right?
C, yeah.
Okay, any doubt?
No, ma'am.
Okay. Okay, so the question number 2 is, so x1, x2 up to xn all are IID following some distribution, okay, where x is a random variable with density function. Okay, density is theta divided by x to the power theta plus 1, and x is taking value greater than 1. Okay, and the sample from the distribution is taken. So the sample is given to you. Then we have to find the maximum likelihood estimate of theta for the given sample. Okay, now solve this question.
And directly, do we need to differentiate this x to the power of theta by theta plus 1, or
Yeah, what you are saying?
we need to differentiate and equate it to 0 to find the
So
theta
first of
value?
all, in maximum likelihood estimate, what we do, we find out the likelihood function first, right?
That's where actually I'm having doubt. Okay.
Yeah, have you all done this question?
Just doing that.
No, I did not do. I'm trying to figure out what is the function. How do we find the
Okay,
function?
okay, I'll solve it. Okay, so in the question, what is given to us? Let me read it again. So here, n IID random variables are given, which are following this density function, right? And then we are given the sample, okay, and we have to find out the maximum likelihood estimate for theta for the given sample. So what we do in maximum likelihood estimate, anyone can explain what is the procedure?
First step is to identify the uh, function, and then we need to differentiate it and equate it to zero to find the value of theta where the function will take the maximum value.
Yeah, so okay, what we do in maximum likelihood estimate. So our objective is to maximize the likelihood function. Okay, so what we do first, so first we try to find the likelihood function. Okay, how we find the likelihood function? It is the product of the PDFs for the given random variables, right? Okay, so first of all, we find the likelihood function. Then our objective is to maximize this likelihood function and find out those values of the parameter or the estimator which maximizes this function. Okay, and for this we use the method of maxima and minima, right? That's why we use differentiation method. Okay, so in this question, so the fx is theta divided by x to the power theta plus 1, and n random variables are given here. Okay, so we will first find out the likelihood function. So it is theta divided by x to the power theta plus 1. Okay, and we have n random variables. Okay, so it will be x1 for x1. This will be the PDF. Then for x2, right? We have to do the multiplication of all for all the random variables for all the n random variables, right? So in this way, we will find out the likelihood function. Is this clear?
Yes, ma'am.
Okay. Now, how we can simplify it? It will be theta to the power n, right? And we can write it like this.
Yes, ma'am.
Is it fine? Okay. So I have written it like this. Okay. Now what we do, we can take log for this function. Okay. So we have to maximization of L will be equivalent to the maximization of log, because log function is a monotonically increasing function, right? So we can take log here. Okay, now what it will be? N log theta minus theta plus 1 log pi of xi, right?
Yes, ma'am.
Any confusion in this?
No, ma'am.
This is clear, right? Now what we have to do? We have to maximize this function. Okay, we have to maximize the equation number 1.
So
Okay, so I hope you have studied the method of maxima and minima. So what we do in that process, we differentiate that function. Okay, so here we have to find out the in the question you can see you have to estimate the theta. Okay, so we have to find out the value of theta for which this function is maximum, right? So we will differentiate it with respect to the theta. Okay, so here we do partial differentiation. So in partial differentiation, what we do, we so here we have to differentiate with theta with respect to theta. So all the other variables will be considered as constant, right? Okay. So
Yes,
the
ma'am.
differentiation of n log theta will be n divided by theta, right?
Yes, ma'am.
And this term, so it will be log pi xi, right? Is this clear?
Yes, ma'am.
Okay, so this will be the derivative. Now what we have to do, you have to put it equal to 0. Okay, so it will be n divided by theta equal to log of pi of xi's. Okay, so from here we will find out the value of theta. So theta will be equal to n divided by log of product of all the xi's. Okay, so you can write it like this also, x1 x2 up to xn. Okay, now you have to put all the values which are given in the question. Okay, so the sample is given to us. Okay, so you have to put all these value 3, 6, 2, 7, 8, 10. Okay, 6 number of sample size is 6 here, so n is equal to 6. 6 divided by log and product of all the variables, all the numbers which are given in the question. Okay, now you can solve it. Okay, now solve the this equation and give me the value. So this will be the maximum likelihood estimate for theta. Okay, so this value whatever comes here will be theta cap. Has anyone solved it?
Ma'am, nearly 1.40.
So here you have to take natural log, okay, not on the base 10.
Yes, ma'am.
It will be around, I think, 0.6 something.
One 1.39 ma'am.
0.605.
Okay, so we have followed this method. Okay, you have to solve this. Value will be 0.60. Okay, again, I'm saying that you have to take natural log here. If you take log on base 10, then the value will be different.
Ma'am, I have a doubt on the partial differentiation where you are solving. So there we had, if we scroll a little bit up, yeah. So the equation one where log L is equal to n log theta minus, that equation. If we
Hmm.
differentiate with that theta plus one log, do we have to solve that using product rule or how is it?
So why will you differentiate it with respect to theta plus 1?
Uh, so we are differentiated with respect to theta plus one. So
Yeah.
like let us say u is nothing but theta plus one, and v will be log of product of x's. Oh,
See, we differentiate with respect to that variable which we have to estimate.
okay. Okay. Okay.
Okay,
So
so here we have to estimate theta.
hmm.
So we will be differentiating it with respect to the theta.
Okay. Okay. Understood. Got it.
Okay, any doubt in this question? Any question?
No, ma'am.
Okay, so question number 3. Okay, so here 4 random variables x1, x2, x3, x4, which are following IID binomial 4 comma p. Okay, so value of n here is 4. Now given a random sample 2043, find the maximum likelihood estimate of p. So here also you have to use the same process. Okay, now here we will differentiate with respect to p. Okay, so first of all, you have to find out the likelihood function, then take log, okay, and then differentiate it and put it equal to 0, and from there you will find the value of t. Is it done? What is the answer?
And was it 0.5625?
Okay, I will solve it. I don't know the answer. Okay, how did you solve it? Same process, right?
Yes, ma'am.
Okay, let me solve this question. Okay, so what will be the PDF for binomial 4 comma p? Yeah, anyone?
It is NCK into p to the power of k into 1 minus p to the power of n minus k.
Okay, and n is equal to 4 here.
4, yeah. 4
Okay,
c
so it will be 4c x or k, whatever you can use. I'm taking here fx. Okay, so it will be x. So 4cx p to the power x
x
and 1 minus p
p to the power of
to the power
n minus
4
x.
minus x, right?
Yeah.
Okay, now we have to find out the likelihood function. Okay, suppose I am representing it by n. Okay, so how will you find it? So here we have four random variables, right? X1, x2, x3, and x4. Okay, so we have to take the product of PDF of these four random variables, right?
Yeah.
Okay, now what will be the likelihood function?
So substitute these four values each time in this function. 4c2 into,
So it will be 4cx1, right?
yeah. Can we directly
Okay, so
substitute the
4,
value itself there too? Yes.
no.
No? Okay.
So that is the sample given to you. Okay, but you have to write the function first. So it will be 4cx1,
Into p to the power of
okay,
x1.
p to the power
One.
x1, then 1 minus p to the power 4 minus x1,
Yeah.
right? And for all the four random variables, we have to write it. Okay, so it will be 4c
0.
x2,
Yeah. 4cx2. Yeah.
4c x2, then p to the power x2, 1 minus p to the power 4 minus x2. Okay, similarly for 3 also, and then I'm writing it for x4, p to the power x4, 1 minus p to the power 4 minus x4. Okay,
Yes, ma'am.
so this is your likelihood function.
Ma'am, actually, I can't see where you're writing.
My screen is not visible.
No, ma'am. Only your this peer deck slide is visible.
No, it is visible,
Sir,
bro.
it is visible.
Okay, let me just reconnect them.
Yeah, we can see
Okay,
that.
okay, yeah. So this will be your likelihood function. Okay, now what we will do? We have to take log of it. Okay, first we will simplify it. It will be 4cxi. Okay, I can write it like this also. Fine. Then p to the power summation of xi, right? You can directly put the values also, but it's
Yeah, correct.
okay. But it's better if you know the procedure, like
Equal
how
to,
we solve questions. Okay, then it will be 1 minus p to the power 4, 4 times 4, because 4 variables are here.
yeah,
Okay,
minus
minus summation of xi's.
x.
Okay, n is 4, so you can directly write it like x1 plus x2 plus x3 plus x4. That is also fine. Okay, now we will take log of it. So log L will be log of this function, this 4c xi, okay, plus it will be summation of xi, okay. So I is going from 1 to 4. I have put the value of n here, log p plus, then it will be 16 minus summation of xi, then log of 1 minus p, right? Now we have to estimate parameter p. We have to estimate p, right? So we will differentiate with respect to p, okay? Okay, so here we can see that p is not in this term, so it will be 0, right? Here it will be summation of xi divided by p, right? Differentiation of log p is 1 upon p, right? Okay, and it will be 16 minus summation of xi divided by 1 minus p. Okay, now we again differentiate 1 minus p, then it will be minus 1, right? Is this clear? How I have differentiated this function? Any confusion?
Yes, ma'am. It's
Okay,
clear.
now we have to put it equal to 0. Okay, so summation of xi divided by p, that will be equal to 16 minus summation of xi divided by 1 minus p, right? Okay, so you have to simplify it, right? So it will be 1 upon p minus 1, which is equal to 16 divided by summation of xi minus 1, right? Minus 1 and minus 1 will be cancelled out. So your p will be equal to summation of xi divided by 16, right? Okay, now you have to put all the values of xi, which is 2, 0, 4, and 3, right? So it is 2, 0, 4, and 3, okay, divided by 16, okay. So the
Point.
estimator of p, which is p hat, will be 9 divided by 16, okay. Fine. Any doubt in this?
Actually, we calculate P. At the end, we say P hat. Why do we say P hat?
See, what we are doing here, we are finding out the estimator for p, parameter p, right? Okay, an estimator we represent, suppose you have a parameter mu, okay, and so estimator we represent it by mu hat. Okay, so here we have find out the maximum likelihood estimator, right? So this 19 upon 16 is the estimate for your parameter. Okay, so this is your estimator, that's why we have denoted it by p hat. Clear?
Yeah, okay.
Okay, so the next question. Okay, so value of p cap, p hat is 19 by 16, 9 by 16. So question number 4 is consider a sample of IID random variables x1, x2 up to xn where n is greater than 30. Expectation of xi is mu and variance of xi is sigma square. And the estimator of mu hat n is given to you. Okay. Then we have to find out the bias of mu hat. Okay, bias of that estimator. Okay, so hat is generally represented the represents your estimator. Okay, this is nothing but your notation. Okay,
I think zero bias.
Yeah, what is the answer?
Zero.
Okay, have you all solved? Okay, so the bias is zero here.
Sorry?
Yeah, bias is zero here.
Yeah, it's zero bias.
Okay, now let me solve it. So the question number 4 is we have to find the bias of mu cap. Okay, so bias is nothing but the expectation of error, right? And error is what? Mu cap, the estimated value of the parameter minus the true value of the parameter, right? Okay, so it will be expectation of mu cap or mu hat minus mu, right? So mu hat is given to us as 1 upon n minus 30 summation of xi's. Okay, and I is going from 31 to n, right? Okay, so this is constant 1 upon n minus 30. So I can write it like 1 upon n minus 30 outside the expectation. Okay, and this will be summation of I going from 1 to 30 and expectation of xi. Is this clear? How I have written this line? So you can understand it like this, that this is the summation of xi. Like, okay, so it will be x1 plus x2 up to xn, suppose. Okay, and you are taking the expectation over the summation. You can write it like this also, summation of xi. Okay, so then it will be expectation of x1 plus expectation of x2 plus expectation of xn, right? So we can write it like summation of the expectation of xi. Is this clear?
Yes, ma'am.
Okay. Now here you can see that in the question, expectation of xi is mu. Okay. So 1 upon n minus 30. Okay. So it is mu and you have to add it for 31 to n. So it will be n minus 30, right? Any doubt in this?
No, ma'am.
Okay, so from 31 to n. So there will be n minus 30 observations, right? So n minus 30 times mu, right? Minus mu. So n minus 30 will be cancelled out. So it will be mu minus mu, which is equal to 0. So bias for mu hat is 0 here. Okay, any doubt? So the question number 5 is, suppose it is known that a sample consisting of the values 15, 16, 10, 8, 7, 9, 20, and 19 comes from a population with the density function. So density function is given 1 upon theta, e to the power minus x divided by theta. So here also we have to find the maximum likelihood estimate of theta. Yeah, what is the answer? Have you all done this?
No, I'm still doing it.
Okay.
Is it minus 13?
Minus.
Minus
No,
13.
it will not be in negative. It should be positive. Okay, so the question is, suppose it is known that a sample consisting of these values, okay, coming from this density function, so we have to find out the MLE of this, MLE of theta, okay. So same process we have to follow here also. Okay, so fx is given to us, so it is 1 upon theta exponential to the power x minus theta, right? Okay, and now we have to find out the likelihood function. Okay, so it will be 1 upon theta e to the power minus x1 divided by theta, right? Then for x2, 1 upon theta e to the power minus x2 by theta up to, for n terms we have to write it. So 1 upon theta exponential to the power minus xn divided by theta, right? So now I can write it like this, 1 upon theta to the power n e to the power minus 1 upon theta and summation of xi's, right? Is it right?
Yes, ma'am.
Okay.
Yes, ma'am.
Now we will take log of it. So log L will be equal to minus n log theta and minus 1 upon theta summation of xi, I going from 1 to n, and it will be log e. Okay. And log e to the base e will be equal to 1, right? It should be equal to 1. Okay.
Yes, ma'am.
So log L will be equal to minus n log theta minus 1 by theta summation of xi's. Okay. Now we have to differentiate it with respect to theta because we have to estimate theta here. Okay. So it will be minus n divided by theta. Okay. Differentiation of log theta will be 1 upon theta. Now it will be, okay. So differentiation of 1 by theta, what it is?
Minus 1 by theta square.
Yeah. Minus 1 by theta square. Okay. So this minus and minus will become plus. Okay. Now we have to put it equal to 0. So n by theta will be equal to summation of xi divided by theta square, right? Now here we can see that n, this theta, 1 theta will be cancelled out. So n will be equal to summation of xi divided by theta. So theta will be equal to summation of xi's divided by n. Okay, now we have to add all the values which are given to us, 15 plus and whatever given to us, and n is the sample size. Okay, so 8 observations are given. Okay, so divided by 8. Okay, now calculate the value. Okay, so that will be your theta hat, ML estimator of theta. Okay, now calculate this value.
Ma'am, it will be 13.
Yeah. So it will be 13. Any doubt?
No, ma'am, all clear.
Okay, so this was your last question for today's solve with the session. Okay, so the same process is written here also. Yeah, any doubt? Then you can ask. Any
Excuse me,
question?
ma'am.
Hmm.
Actually, I missed the last question solution. Could you please show once again?
Yeah, sure. Question number 5, right?
Yes, ma'am. Okay.
Can you spell log part, please?
Sorry,
Log part.
log this step.
Yes, ma'am.
Okay, so what we have done, we have taken log. Okay, so see, this is in the denominator. Okay, so like it is theta to the power n. So whenever we take log of something and the power comes before the log term, so it will be n log theta. Okay, and this term in the denominator. Okay, so this is the formula, log m divided by n. So this is equal to log m minus log n, right? So I
Yes,
have
ma'am.
used this formula. So this will be minus n log theta, right? And here this power will, like this is in the power of exponential. Okay, this term comes here and it will be log e. And log e to the base e is equal to 1, right?
Yes, ma'am.
Okay, now what we have done, we have differentiated it with respect to theta. Okay, so differentiation of log theta with respect to theta, it is 1 upon theta. Okay, so it will be minus n into 1 upon theta. Okay, and here, so here it is del by del theta of 1 upon theta. Okay, so it is equal to minus 1 upon theta square. So that's why this minus sign will become plus, minus minus will become plus. Okay, and it will be summation of xi divided by theta square.
Okay, ma'am.
Okay, then we have put it equal to 0, and from here we have find out the value of theta. Any other doubt? Any question?
No, ma'am.
Okay, so if you don't have any doubt, then we can end the session.
Okay, thank you.
Okay, thank you all.